Hi kids, my name is Mrs. Compton and you may have seen me around your school or maybe even in your classroom. I love to do math and so I'm here to do some math with you today. So today we're going to talk a little bit about metric measurement, which I love because everything's all around 10, and how that can relate to tenths. So real quick, let's review. So if we were to have the ones place here, the next thing we'd have would be a decimal, and then we'd have the tenths place and the hundredths place. Now, sometimes it gets confusing because we've got the ones place and a decimal, and then 10 sounds like it's greater than 1, but it actually isn't. It's worth 10 times less. So if I were to put a 1 right here, and I was thinking about money, that'd be worth $1. If I were to put a 1 right here, that would be worth, you guessed it, 10 cents because it's 1/10 of $1. And if I were to put a 1 right here, that would be, guess which coin it would be if we're thinking about money? That would be, you're right, a penny, because we're thinking about 1/100th of $1, right? So these are increasingly getting smaller as we are going to the right of the decimal, right? And earlier this year, you learned that every time it goes one place to the right, it decreases in value by 10 times that amount, right? So it's actually worth 10 times less, which is the same as divide by 10. Okay, that's just a little bit of a review for getting started in metric measurement with tenths. So it's important to kind of remember that not just whole numbers can go on a number line. Fractions and decimals can too. So let's check out a number line like that. So if I were to put 0 here and 1 right here, what could you tell me about this number line? What could you tell me? I bet some of you know that you could put a halfway point on there. Did you think about that? So you could put a halfway point right there. That would be about halfway. Now I'm doing this with my hand, so it's not perfect. So I'm just trying to get things to look about just right. I think that might be it. Okay, so I'm going to call that my halfway point. So I guess I could write, that for half. Now I know that's half because when I read this decimal, I say the word 5, and then it's in the tenths place. So 5/10, which also is equivalent to this fraction. So it's really important to say this correctly because it tells us the fraction in our minds. Okay, so this is said 5/10, and it responds to or relates to this fraction, 5/10. Now, I bet you already know that this is worth half because 5 is half of 10. So we know that the fraction 5/10 is the same as the decimal 5/10, and they're both the same as half. All right, I'm going to guess that some of you probably thought that. So let me see here. What else could we do here? I have a guess. I'm going to guess that some of you probably said, if that's 0 and that's 5/10, then this would be 10/10 right here. So maybe some of you thought about that. And then maybe some of you were saying to yourself, well, we could just write 1, but we could put it in decimal form. So maybe you thought about that, and we would just put a decimal and a 0. That's pretty nice to do. It's pretty easy. And then this over here would be 0/10. Same as a big fat goose egg, 0. All right, so if we know that, then can we break this down into even smaller increments? So if this is 5/10 and this is 0/10, what would go between them? More tenths, you say? I think so. Okay, so let's see here. I'm going to try to get between 0/10 and 5/10, everything placed fairly correctly. So I'm going to do my estimation here. So let's count together. 0 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths. Okay, so it looks like I got these placed about a similar distance, so I think I did okay on that. Now, we know that these are the decimal fractions, or we can write the decimal fractions for these fractions that we just listed. So we need the decimal, and then we need the 1 to end up in the tenths place, because that's what this is telling us. So 1 tenth. All right, same for 2 tenths. 2 tenths. Okay, 3 tenths. 4 tenths. Again, we don't say 0.1. We're mathematicians. We know how to say these things correctly, right? So we say 1 tenth. So 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths. Let's try some more. We've got 6 tenths, 7 tenths, 8 tenths, 9 tenths, and 10 tenths, or 1 whole. So again, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths. Count with me. 6 tenths, 7 tenths, 8 tenths, 9 tenths, 1 whole. All right, so that's one way of looking at this, but then sometimes, you know, in 4th grade, we've seen a lot of tape diagrams. So it's nice to think about this, turning this into a simple tape diagram. So you could just close these guys up. Let's do it, actually. Let me switch out my color, and let's just do it. Here we go. I'm going to erase my endpoints, and I'm just going to show you how I think about it in my brain when I'm like, ooh, I want a tape diagram. There we go. And then I'm just going to make my lines a little bit more clear. Voila! I've got a tape diagram, and now I can just take my middle line out. So we just saw that a tape diagram is just like a number line, which is kind of crazy and kind of cool at the same time. So if I said, okay, shade up to 5 tenths, well, you could say, all right, I can do that. I'm going to get my favorite color, which is orange. And you could just say, all right, I've got to go up to the 5 tenths. Remember how we used to do that with tape diagrams earlier in the year? So 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths. All right, kids, so that is one way of thinking about it. Now, when I was thinking about this lesson, I actually had some of my kitchen tools out, and I was looking at this. You probably can see the words a little bit, but not that great. So I made some food dye water, or water with food dye in it. And so I'm going to fill it up a little bit so that you can see. But you can see up here, it says, whoop, right there, 2 liters. So if this whole thing is 2 liters, half of it would be, what do you think? I'm going to guess that you probably know. All right, so here's my water with food dye. So this is a 1 liter bottle. So just take into consideration when you go to the grocery store, usually things come in a 2 liter, right? So this is 2 liters. This is 1 liter. All right, so check this out. I hope I don't spill this. I am kind of known for my clumsiness, so here we go. All right. There we go. You can see it's filled up to the 1 liter mark. And you can see it also says 1,000. Those are milliliters. Okay, woo, woo. But I wanted you to notice this. See, they have these other lines right here. They have 10 marks on there. So it's kind of strange, but you can see that a number line is actually on here. I'm gonna get in trouble for writing on my kitchen stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, whoop, I'm tilting this thing all around, you guys. So when you look at it, this thing actually had the lines already written out on it. So this is 1/10, 2/10, 3/10, 4/10, 5/10, which is the same as a half, 6/10, 7/10, 8/10, 9/10. Oops, wrote that backwards. And 1.0, otherwise known as 1. So the point of this is really for you to see there are number lines literally everywhere. I didn't notice this number line until today, but I want you to pay attention to things around your house, whether it's a thermometer or if it's a thing in the kitchen, a tool. Check it out and see if you can find number lines around your house. All right, guys, thanks for tuning in. See you next time. Bye.